Imagine a substance that has the properties of a solid but can flow freely like a liquid. Sounds impossible, right? Well, scientists have just made it possible. In the fascinating world of quantum physics, we encounter some truly mind-bending concepts. One of them is the idea of a supersolid. A supersolid is a paradoxical phase of matter that behaves like a solid maintaining a rigid shape, yet it also flows without viscosity, much like a liquid. But wait, there's more. Enter quasiparticles. These aren't particles in the traditional sense. Rather, they are disturbances or excitations in a system that behave as if they were particles. They possess energy and momentum, but they are not matter as we typically understand it. Quasiparticles are a bit like the ripples on a pond after you throw a pebble in. They're not the pebble. They're the result of the pebble's interaction with the water. So what happens when these two seemingly opposite entities come together? Let's explore. Scientists have successfully turned light quasiparticles into a supersolid, marking a first in the world of physics. Now let's delve into the experiment that made this breakthrough possible. Imagine light trapped in a structure that has all the properties of a solid. This might sound like something straight out of a science fiction novel, right? Well, not anymore. Scientists have managed to do just that, creating a new exotic phase of matter. To achieve this, they used a semiconductor and laser light to produce what are known as polaritons. These polaritons are light quasiparticles, a type of particle that behaves as if it were a particle of light. But creating these polaritons was just the tip of the iceberg. The real challenge was getting these light quasiparticles to form a supersolid state, a state where matter exhibits properties of both solids and superfluids. This was a tall order considering the complex and delicate nature of the process. So, how did they do it? Well, they had to carefully manipulate the polaritons, effectively corralling them into behaving like a supersolid. This was a delicate balancing act, as they had to maintain the integrity of these light quasiparticles while coaxing them into this new state. The process was akin to trying to herd cats. Tricky, but not impossible. With a mix of precision, patience, and a deep understanding of the underlying physics, the scientists overcame these challenges, marking a significant milestone in physics. But what does this all mean? Why go through all this trouble to create a supersolid out of light quasiparticles? Well, it's not just about creating something cool or novel. This experiment is a stepping stone towards understanding and harnessing the potential of supersolids. It's about pushing the boundaries of what we know and exploring uncharted territories of physics. This is not just a scientific curiosity. It's a breakthrough that could open up new possibilities in the field of supersolidity and many-body photonic physics. So why does this matter? Why is the creation of a supersolid from light quasiparticles a significant achievement? Well, let's delve into that. This groundbreaking experiment opens up an entirely new realm of possibilities in the fields of supersolidity and many-body photonic physics. Imagine a new exotic phase of matter that has the properties of a solid but can flow freely like a liquid. It's pretty mind-bending, isn't it? But let's take a step back and remember what we've discussed. Light quasiparticles, also known as polaritons, were produced using a semiconductor and laser light. These polaritons were then manipulated into a supersolid state. This fascinating process essentially trapped light in a structure that behaves like a solid, yet retains the fluidity of a liquid. And why is this important? Because this achievement could potentially revolutionize our understanding of matter, and even alter how we interact with the physical world. It's a big deal. So, there you have it, the first ever creation of a supersolid from light quasiparticles, a breakthrough that could change the way we understand and interact with the world around us.